Welcome to NASA Edge, an inside and outside look at all things NASA. Today we're here with the second part of an interview we're doing on the precise landing technology called SPLICE. I'm joined today by Ron Sesteric and Glenn Hines, who both work on this project. My question for you, Ron, is remind us again, what is SPLICE and what is your role with this program?
Hi, SPLICE is a safe and precise landing technology development project that's developing technology for landing on other planets and other planetary bodies. Our big challenge is to try to land both safely and accurately on other planets, and we're developing avionics, sensors, and gene and C technologies to improve the state of the capabilities for human spaceflight and robotic spaceflight to land.
Now, this technology, SPLICE, is going to be used on a future Blue Origin launch. How did Blue Origin come by being an industry partner for NASA to use SPLICE?
So NASA developed an agreement with Blue Origin under the Tipping Point program. The idea behind Tipping Point is that it's intended to test technologies that are close to a tipping point. It's a partnership with both industry and NASA to take technologies that next step over the tipping point and get them into space.
Now, Glenn, we've worked with you and NDL on an earlier NASA Edge show. For those who haven't seen that program, can you tell us exactly what is NDL and how does it work?
Okay, NDL, Navigation Doppler LiDAR, is a laser-based system where the laser beam is fired out of 3 telescopes. These telescopes will be mounted on the side of a landing vehicle, and they're pointed down to the ground. The laser beams will come out of the telescopes, strike the ground, in this case the moon's surface, and be reflected. Part of that light will be reflected back into those same telescopes. And what we do is we combine a little bit of the outgoing signal with that returned laser beam signal. When it comes back into the system, it is shifted, and we are able to use those shifts in information. Time delay gives us the range, the shift in frequency gives us the velocity using the Doppler effect, and we can generate a very precise velocity and range information out of that processing.
Now, this question is for both of you. How important is SPLICE to the New Shepard launch and to Artemis and future commercial partners that need this precise landing technology? Ron, you can take it first.
SPLICE is developing these technologies and working with Blue Origin to get them first tested on the New Shepard rocket here later this year and again next year to show the terrestrial demonstration capability of an integrated descent and landing system. From there, the goal is to get it to the moon as soon as we can, and so the shortest way to get it to the moon is to fly it on a robotic mission. Right now those are funded, it's called CLPS, it's Commercial Lunar Payload Services. And so the plan is to take these technologies first individually, especially the Navigation Doppler LiDAR, NDL, the most mature of the technologies, and later, as the other ones become mature, add them into the integrated system, fly them first on robotic missions, and then make them available for human missions in the future.
Glenn, can you expound upon the thought of how this technology will be demonstrated with New Shepard, and then how it can be expanded to Artemis in future missions?
Sure. So on the New Shepard flight, it will be integrated onto the rocket, and our telescopes will be looking down at the ground. What happens for New Shepard, though, it goes pretty much straight up, goes exo-atmospheric, and then comes straight back down. So what this provides us is data going up and down, and it also takes the system, puts it into a vacuum. So we get the full range of temperatures, pressures, and we get data going up and coming down throughout the entire flight for Blue Origin. And data is king. We need to collect as much data as we can to learn as much as we can about the system. This Blue Origin flight gives us a ton of test data to help ensure that the systems that we're building for the moon are robust, reliable, and will be working in great condition for those missions. As you know, when you're flying people, you have to be grade A totally reliable. You know, we do not want to have any kind of errors or mistakes at that point in time. So we want to be as safe as we can with our technologies at that point in time. And these precursor missions gives us the opportunity to eke out problems, issues, learn about the behavior of the system in space, and it provides us a much higher level of reliability when we're going into the Artemis missions.
Ron, what legacy technology was used from Apollo to assist in the development of SPLICE?
So back in Apollo, during the lunar landing, the humans did a lot of work during the landing to first confirm that people were where they thought they were. Basically, they looked out through the window to confirm that the landforms were what they had trained to see and what was expected. So SPLICE is adding technologies in that will both alleviate the need for the human to do all the work and help provide the human with awareness. So through the use of cameras, we can do what we call terrain relative navigation, or TRN, and that's the idea of updating a navigation estimate based on imaging the landforms. Much in the same way that the human was doing qualitatively in Apollo, we can do it quantitatively. At the same time, those same cameras can be used to give the human the picture so that they have a comfort that they are where they expect to be at that point in the mission. As we get closer to the ground, we have another technology for hazard detection. So there's 3D LiDARs that SPLICE is helping to develop that will allow a real-time 3D map to be generated of the landing area. This 3D map can be used to determine where their hazards exist, whether they're rocks, slopes, craters, or pre-placed assets. And then the spacecraft can maneuver to avoid any of these hazards and come in for a safe landing.
That is awesome. We thank you for being on the show today, and we look forward to the New Shepard launch and the demonstration of the SPLICE precise landing technology.
Thanks for having us.
Yeah, thanks for having us. Really appreciate it.
You're watching NASA Edge, an inside and outside look at all things NASA.